3-6 is all about triangles. And the first thing that we're going to do is classify triangles in two different ways. So first way that we're going to classify them is by angles. So if you have 3 acute angles in a triangle, remember acute means less than 90. So if you have 3 angles in a triangle that are all less than 90 degrees, that's called an acute triangle. If you have 1 angle that's obtuse, that's going to be an obtuse triangle. Okay, you can't have more than 1 obtuse angle in a triangle. If an obtuse angle is greater than 90, even if it was 91, and you had another angle that was also 91, just 2 angles of the triangle would be more than 180. So again, you can't have more than 1 obtuse angle in any triangle. So an obtuse triangle just has 1 obtuse triangle. Our 1 right angle would be a right triangle. And then 3 congruent angles is equiangular. Okay, equi meaning equal, angular meaning angles. So 3 equal angles. If you classify it by sides, if you have 3 congruent sides, that's going to be equilateral. Okay, lateral being side, equi being equal. So 3 equal sides. So you have an equilateral triangle is also equiangular, but again, if you're classifying it by angles, it would be called equiangular. And if you're classifying it by sides, it would be called equilateral. If it has 2 congruent sides, it's called an isosceles triangle. An isosceles triangle also has 2 congruent angles in it. But again, when you talk about an isosceles triangle, we are classifying it by side, not by angles. And if you have something that has no congruent sides, that's scalene. So the first thing that we're going to do is classify each of these 3 triangles by its side and by its angles. So for number 1, I have 3 equal angles. So I'm going to write A for angles and then S for sides on how to do it. So if you're classifying it by angles here, this is equiangular. And if you're doing it by sides, I have 1, 2, 3 equal sides. That's equilateral. Okay, for our second one, I have a right angle or a right triangle. And then I also have 2 congruent sides. So if I want to classify it by angles, it's going to be by that right angle. So that would be a right triangle. And if I want to classify it by sides, it has 2 equal sides. That's going to make it isosceles. And for number 3, I have 1 angle that's greater than 90. That's an obtuse angle. So by angle, that means that that's an obtuse triangle. And then classifying it by sides, this has no equal sides, so therefore it's going to be scalene. Okay, and that's classifying triangles by sides and angles. Okay, so now let's put all of that into use into some examples here. So for number 4, if triangle MNP is an equilateral triangle, I want to find X. Hey, equilateral, all equal sides. Hey, I've given 3 different expressions here. Okay, but you only need 2 in order to write the equation, and it does not matter which 2 of the 3 you use. You just can't use all 3. So I'm going to use the x plus 14 as my one side, and I'm going to use 4x minus 25 as my other. Again, it does not matter. You could have used 6x minus 51, but you can only use 2 out of the 3. So again, equilateral means that all the sides are equal. So I'm going to set x plus 14 equal to 4x minus 25. Subtract x from both sides. And 14 is going to equal 3x minus 25. Add 25 to both sides. And 39 is going to equal 3x. And then divide both sides by 3. And x is going to equal 13. It only asked me to find x. I found it. I'm done. For number 5, if triangle WXY is an isosceles triangle with WX congruent to WY, find X. Again, this time, unlike the problem that we just did, it does matter which two that you set equal to each other. An isosceles triangle only has 2 sides that are equal, not 3. And they're telling you right here which 2 sides are equal. So WX equals YX. Okay, so I cannot use that 5x minus 31 in any way, shape, or form in this equation. It's only going to be the 3x plus 4 that's going to be equal to the 6x minus 77. So 3x plus 4 equals 6x minus 77. Hey, again, it doesn't matter what you do first here. I'm going to subtract 3x. Those will cancel. So I'm going to be left with 4 equals 3x minus 77. I'm going to add 77 to both sides. You're going to get 81 equals 3x. Divide both sides by 3. And x is going to equal 27. Again, the question asked me to find x. I found x. I don't have to plug it back in. I'm done. Okay, so parts of isosceles triangles here. Okay, 2 congruent sides in isosceles triangle are called legs. So in the triangle that you're looking at here, your legs would be AB and BC. The angle where the legs intersect is called the vertex angle. So again, if I highlight those legs, the angle that's formed is angle 1. So angle 1 is your vertex angle in that picture. The side opposite the vertex angle is called the base. Directly opposite angle 1 is side AC. So AC is your base there. And the angles along the base are called the base angles. So after I have that one at the top, the vertex angle marked off, your other 2 angles are your base angles. So it's going to be angle 2 and angle 3. Okay, and it's these base angles that are always congruent, that are your 2 equal angles there. They're going to be congruent. So here's what the isosceles triangle theorem says. If 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So again, if I start with this triangle on the left with A, B, C, and I know that AB is congruent to BC, if I go to the angles directly opposite those congruent sides, I would have angle C and angle A. So that means that angle A is going to be congruent to angle C. And that's what this picture over on the right-hand side says. You can also say the opposite of that, the converse of the isosceles triangle theorem. So if you knew that the 2 angles were equal, then I can also tell you that the sides opposite those angles are equal. So if I was given angle A is congruent to angle C, I want to go directly opposite angle A, I would have side BC. And then if I go directly opposite side C, angle C, I'd have side AB. So that means that AB is going to be congruent to BC. Okay, so based on all this information, all these definitions that we know, and the fact that you have 180 degrees in a triangle in total, now we're going to use everything, put it together, and see if we can find our other angles here. So for part A, again, the fact that these 2 have hash marks through them means that those 2 sides are equal. So again, that means it's an isosceles triangle, and that means the base angles of an isosceles triangle are congruent. So angle L is one of your base angles, and angle J is your other base angle. So that means angle J is going to be 68 degrees. Okay, and then we want to find out what angle K is. Again, there's 180 degrees in a triangle, and you've used 68 once, twice. So if you take that 180 and get rid of 68 twice, you should end up with an answer of 44. So that vertex angle here is going to end up being 44. Okay, for part B, again, I have another isosceles triangle, but this time, instead of being given one of the base angles, I'm given the vertex angle. Again, if I trace the 2 sides that are congruent, it forms that 106. Okay, so that's the vertex angle. And my other angles, C, and E are the ones that are equal. So if you wanted to write this as an equation, if I called this one X, the bottom one would also be X. So you could say X plus 106 has to equal 180. You don't have to write an equation. You could have just taken the 180, got rid of the 106, and then divided by 2. It's completely up to you. When I subtract the 106 from both sides, I should get an answer of, and I'm going to combine them. X plus X is 2X, and 2X is going to equal 74. Divide both sides by 2, and X is going to equal 37. So both the measure of angle C and E will both be 37 there. For number 7, for part A, again, I have an isosceles triangle, and this time I have the two base angles of the isosceles triangle. So again, I don't know anything about the third angle, so there is no adding up to 180 here. Okay, I'm just going to set those two angles equal to each other because the base angles of an isosceles triangle are congruent. They're equal. So we're going to set 5x plus 9 equal to 8x minus 30. Okay, again, doesn't matter what we do first. I'll subtract 8x this time. So I'm going to have negative 3x plus 9 equals negative 30. Subtract 9 from both sides. And negative 3x is going to equal negative 39. Divide both sides by a negative 3. And x is going to equal a positive 13. Okay, and then for part B, again, here are my angles that are congruent. And again, it's going to be the sides opposite those angles that are congruent. So opposite that would be the 15x plus 7. And opposite your other angle would be the 23x minus 17. So to solve for x here, we're going to take 15x plus 17 and set it equal to 23x minus, I wrote that wrong. Hold on. I took one part of one equation, one expression, and one part of the other. It's going to be 15x plus 7 equals 23x minus 17. Again, doesn't matter what you do first here. Makes no difference. I'm going to subtract 15x from both sides. So we'll get rid of those. So I'm going to be left with 7 equals 8x minus 17. I'll add 17 to both sides. And 24 is going to equal 8x. And then the opposite of multiplying by 8 is to divide by 8. And 24 divided by 8 will be 3. Again, only asked me to find x. I found it. I'm done. Okay, and then for our equilateral triangles, again, I had said this earlier in the video, if a triangle is equilateral, it's also equiangular. Okay, so if I know that angle A is congruent to angle B, which is congruent to angle C, then I can also tell you that AB is going to equal BC, which is going to equal AC. Okay, and then the exact opposite of that is going to be true. If I tell you that all three sides are equal, so if AB equals BC, which equals AC, then the three angles will be equal. So the measure of angle A is going to equal the measure of angle B, which is going to equal the measure of angle C. Okay, so each angle of an equilateral triangle, no matter what the lengths of the sides are going to be 60 degrees. Again, you have 180 degrees in a triangle, and you have three angles that are equal. So if you take that 180 and divide it by 3, you're going to get that 60 degrees. So for our last question here, if triangle PQR is an equilateral triangle, we want to solve for both x and y. Hey, again, first thing I'm going to do, I'm going to concentrate on x here first. Hey, that one angle is 60 degrees. Again, I don't know anything about the other two angles right now. I do. They're all 60. But in order to solve for x, I don't need to put them into the equation at all, I should say. So we're going to have 7x minus 3 is going to equal 60. Add 3 to both sides. And I'm going to have 7x equals 63. And we're going to divide both sides by 7. And x is going to equal 9. So that takes care of our x. Now we have to solve for our y. Again, it's equilateral. This is like the first problem that we did. It's equilateral. You can pick any two sides to set equal to each other. You can't use all three to write an equation. So you just have to pick two out of the three sides. I'm going to do the 9y plus 1, and I'll do the 14y minus 59. So I'm going to do 9y plus 1 is going to equal 14y minus 59. Again, it does not matter what you do first here. I'm going to get rid of my 9y. I like having positive x coefficients of x. Just a personal preference. It's a weird habit of mine. Okay, so I'm going to be left with 1 on the left, and on the right, 14y minus 9y will give me 5y. And then I'll add 59 to both sides. So I'm going to have 60 equals 5y. And then divide both sides by 5, and y is going to equal 12. It only asked me to find x and y. It didn't ask me to plug it back in and find anything else. So at that point, I'm done.